Hi, welcome back. In this lesson, we're going to introduce you to or review basic PKI concepts and how they are utilized in an ISE deployment. We're not going to go into depth in PKI, but just high-level specifics or highlight the specific points you need to know when deploying ISE. At the end, we'll do a quick demo of generating a signing request, signing that certificate, and preparing 2 ISE servers to be part of a deployment. Let's get certifying. See what I did there? Hopefully by now, you've had some exposure to certificates and public key encryption, whether it be just using a web browser and getting the occasional warning in your browser that there's a problem with the website, or you've actually had to implement an application or connectivity that makes use of PKI. PKI uses both a public and a private key. The public key is known to all. The private key is only known to the owner. The owner signs a message with the private key, and only the public key can decrypt this message. So just to review, a certificate is basically a signed document that is issued by a trusted source that generally is verified by some type of insurance or bonding that proves you are who you say you are, very similar to a driver's license or a passport. It not only provides authentication services and data encryption, but also provides integrity verification that the message has not been tampered with in transit. ISE uses PKI to secure communication within the ISE system and the ancillary systems communicating with it as well. And it also uses it to verify the integrity of the information between the nodes. ISE has 2 types of certificates that we're going to review. There are system certificates, which basically identifies ISE to the other systems and are bound to the services that ISE offers, for instance, the admin service, or the policy service for an EAT-based authentication, or the web portals from a guest or BYOD perspective. And then there's trusted certs. So these are the certificates that ISE trusts. So when certificates are presented to ISE as part of an initiation or a session, ISE will trust the issuers of these specific certificates. ISE uses certificates when securing user functions. A user identity can be verified with a certificate, meaning John Doe can present a certificate proving his identity during an authentication. The same structure holds true for a device authenticating. The device can present its certificate to validate that he is who he says he is. This is the one most people are most familiar with, which is the website identity. The certificate presented by a website validates that the website is who they say they are and that the information has not been tampered with in transit. And in all of these cases, the certificate is used kind of as that seed value for encryption as well. So looking at what we just reviewed, if we look at the ISE options that will use the system certificate, we have the admin node and securing communication in between the ISE services and the user interface. We have EAP or TLS authentication that secures the authentication from the endpoint's perspective. We have certificates used in radius authentication if we're using secure radius or DTLS-based authentication. We have certificates for the portals, whether they be the web portal, the sponsor portal, there are certificates that are used there as well. And PXGrid uses a certificate-based authentication method to verify each system connecting into that environment. ISE does come pre-installed with some self-signed certificates. Self-signed certificates are basically certificates that the server itself signs. Enterprise deployments typically do not use these and use either a public CA or their own enterprise CA. Self-signed certificates are generally used in a lab scenario or in very small, limited environments. So let's look at some terms that you should know. A certificate authority, we talked about before, is basically the organization that validates you are who you say you are and actually issues that certificate to you. So when you generate a certificate signing request, you will send this to a certificate authority. They will validate your business status, whether you own the domain, et cetera, and they will sign and vouch for you that you are who you say you are. The root certificate is basically the certificate that validates that CA's identity. So the root certificates are basically the top of the tree from that perspective. and they sit over all the certificates and validate that they are who they say they are. You can have what's called an intermediate certificate in the chain. An intermediate can sign on behalf of a specific certificate authority. If you look at most certificate authorities, their root certificate does not sign your request. It's signed by an intermediate certificate further down on the chain, which leads us to the chain of trust. If we look at certificates, it's basically a tree-based architecture to where we go up the chain to get to the root. That chain of trust is very important, and the full chain of trust needs to be installed in ISE for things to work correctly. We already talked about this before. The public key is the part of our certificate that is available to everybody. Everybody has our public key, and then we have our private key. Our private key is only known to us. We sign a request with our private key, and only our public key can decrypt those. Then the last thing we're going to talk about is what's called a SAN, the subject alternative name. This is basically another name that's stored as an attribute in the certificate that can be used to secure a specific server with that DNS name in the certificate. If we look at validity of the certificates and how they are valid or when they are valid too, certificates are only valid for a specific date range. When it expires, the behavior of the ISE functionality is really kind of dependent on what type of certificates you're using and where they are used in the system. ISE does have warnings that come out within 90 days to notify you that things are about to expire. If it's a self-signed certificate, I can go into ISE itself and extend that expiration date just by editing the certificate. However, CA certs are a little bit different. You can't go adjust the expiration date on these. The issuer of the certificate must actually reissue a new cert with new dates. This takes some time, so keep that in mind when looking at the certificate life cycle in your environment, that you are going to need time to actually reissue these with newer dates and renew these. So there's a few options in using certificates in your deployment. Several factors will influence your decisions, including ease of administration, end user experience, and your company's security policy with regard to PKI. You can use a single certificate for all services on each node in the deployment. All services would share the same certificate on an individual node. You could use a different certificate for different services, meaning you could have a certificate for admin, a different one for authentication, and a third one for portal. You could use the same certificate on all PSNs, meaning you will request the certificate from one node, bind that certificate to that node, then export both the public and the private key and re-import that into all the remaining nodes. Or you can use wildcard certificates. Wildcards are where we allow you to use the same certificate for multiple hosts that have the same DNS suffix, and we'll talk more about that in the next slide. You can use any combination of these as well. It's very flexible, which can sometimes be both a good and a bad thing. We mentioned wildcard certificates in the previous slide. Wildcard certificates allow you to use the same certificate on multiple hosts that share a common DNS suffix. For example, if you wanted to make your ISE installation part of its own common domain, say ice.company.com, you could use the same certificate for all the servers in the ice.company.com domain. pan.ice.company.com, mnt.ice.company.com, or psn.ice.company.com. ISE supports wildcard certs for admin and EAT protocols as well as portal components. Typically, most security organizations don't like wildcard certificates and consider them somewhat less secure than individual certificates, as you don't have individual attribution to the server that was requesting the services. So why might you want to use a wildcard? For one, there's typically a cost associated with most certificates if you're using a public certificate. We generally see improved administrative efficiency and end user experience while requesting services from different nodes with a wildcard certificate. Sometimes there are challenges with how each endpoint's operating system evaluates certificates, and using wildcards can create a consistent user experience. Disadvantages. As we've talked about before, there is a loss of attribution, as I can't tie this certificate to an individual server. there is sometimes an increased exposure or the perception of increased exposure of that private key because I have to import and export that private key to each of the servers in the environment. And a lot of times people don't exactly understand what wildcard certs are, and sometimes that can be misunderstood by administrators and lead to increased exposure as well too. There isn't really a right or a wrong answer as to should I use a wildcard or not. It really comes down to your environment, how you want to manage it, and your security requirements around certificate usage in the environment. When matching certificates, let's take a look at how this flow works. So first of all, ISE is going to look at that SAN, or that Subject Alternative Name field of the extension of the certificate. If the SAN contains the DNS name that's being referenced, one of those must be the FQDN of the ISE server, then it passes. If a wildcard cert is used, then it has to match the ISE fully qualified domain name. If there aren't any DNS names, then it falls back to the common name in the subject field of the cert, which in essence is the server name. If none of these match, the cert is rejected. So that's a very simple order for you to follow when doing your validation to make sure that the certificate is going to be accepted by the communication. There's 3 types of certificates. Let's talk about those real briefly. We already talked a little bit about this. There's a self-signed certificate. So this is the certificate that is signed by the server itself. Disadvantages of this is every end system that references this certificate will need to trust the server that signed the certificate. So as you can see, it's not really manageable in an enterprise environment. There's a public CA, which is the company that we talked about earlier. It's an external entity that takes your signing request, validates your company status, your DNS ownership, and a lot of different factors, and signs that certificate for you to validate that you are who you say you are. The third type is a private CA, and this is typically what we'll see in most ISE deployments for the endpoint authentication. These are certificate authorities that are managed as part of the enterprise. One of the most common ones we see is Active Directory, because Microsoft has a CA that is embedded with Active Directory and just works in conjunction with it, and we just use that as our certificate authority in the ISE implementation as well. Just some real quick screenshots, and we'll go over these in our demo a little bit later. But as you can see, ISE has the 2 certificate types that we talked about before, the system certificates and the trusted certificates. These are our system certificates. We have a name for that certificate, which is just a name that defines the certificate to us, what function that certificate is used for. So remember I said certificates can be used or individual for specific functions, whether it's the admin portal, whether it's pxgrid, whether it's authentication. This just gives us a very quick way to understand what function that certificate is. Who it was issued to. It was issued to our ISE server. Who issued the certificate, and the valid dates. These are key ones to keep note of in this specific example. Trusted certificates. As we talked about before, these are the certificates that when presented, ISE will trust. You can see the expiration column that we've got one that is either going to expire or about to expire, so you can get a really quick view of the status of your certificates and try and preempt problems in your environment. Remember we talked about that chain of trust, that there is sometimes an intermediate certificate in the chain. Remember that from an ISE perspective, we always need to have the full chain of trust imported. So just because you import the signing certificate does not mean the full chain is actually going to be there and ISE is going to be able to validate that certificate. GoDaddy is a common example to where they have a root certificate and a certificate that actually signs the certificate that is issued to you. So as you see here, I have the root certificate and the subordinate certificate both in the certificate chain, and then I can view those and validate that the complete chain is there. One last thing to note, ISE does have its own internal CA. This is a self-contained CA that we can use for specific workflows like BYOD or supplicant provisioning. The internal CA, like we said, is best suited for specific use cases. I can also use it for pxgrid participants, so I can issue certificates to pxgrid participants and have those certificates managed by part of this internal CA as well too. it is not meant to be used as an enterprise CA. So if you don't have an enterprise CA, it is not recommended that we use this for that example. So we talked about BYOD or MDM, or one of the primary use cases. Why would I want to do this? The internal CA simplifies ISE deployments, meaning I don't have to work directly with the enterprise CA team to issue those certificates to BYOD endpoints. ISE can manage those directly and issue those directly to the endpoints themselves. Now, I can work with an enterprise CA and be part of that trust hierarchy if I want to, but I don't have to burden those, and I can manage those as part of the overall ISE implementation from a network access perspective. This is a document that I recommend you read. It goes into a lot more detail in the topics that I just talked about and goes over a lot more use cases from that perspective. So please reference this document for much more information. That being said, next thing we're going to do is actually do a demo of issuing a certificate, signing a certificate, binding a certificate, and getting ready to join an ISE cube together.